Welcome to the engineering support by James video number 7. In this video we are going to discuss about support reactions of the beams with internal hinge. It is also called as a shear splice. So what is splice connection first of all? So in this first figure or snap you can see it is around 14-story building. So let us assume the floor to floor height as 3 meter 14 into 3 is around 445 meters or 50 meters, let us assume. So you are not going to uh, get the member of 45 meters at one stretch. You cannot build it. Okay, it also having some connections, lots of things are there. So we use these types of members when this is a angle section, this is channel section, this is T, this is I section or white flange you can call it as. This T section is nothing but the half cut of this. These are circular solid section, these are rectangular, these are the plates, these are another construction material, this is plate, this is checker plate. So there are many things required, and manufacturer have some limitations. He can manufacture it for around 12 meters, and suppose he will manufacture it more than 12 meters, maybe 20 meter 30 meters. So how will you transport it? You can't transport it. Means if you want to construct something in the middle of the city and you have to transport this 12 meter or more than 12 meter length of these types of members, steel members having huge weight in tons, so it cannot be transported from one place to another place easily. At the same time, where to store them? So there are many difficulties. So 12 meter is the manufacturer length available in India. So other countries could be around 12 or 15 meters, but not more than that due to this transportation issue. So whenever the beam or the column length of steel section exceeds 12 meter, it is necessary to provide splice. So there are two types of splices. One is moment type connection and another one is shear type connection. So shear type connection is nothing but the internal hinge. So what is moment connection splice is, here there are two connections here, figures are there for two types of splice connection. One is bolted, another one is welded. So in this case there are three types of forces. One is the axial force, which I am neglecting in this figure. I'm only showing you the moment and the shear. So your moment type connections takes moment as well as the shear and the axial force also, which I have neglected. So next is the splice with the shear connection only. So in this case there is no flange plates we have provided. We have provided only the web plates. So these web plates are capable to carry only the shear. They cannot take the moment. So these types of connection, this is called as shear connection splice, and this is nothing but internal hinge support. So for practical purpose, we don't really use this. We always use the moment type connection. We provide flange plates along with your shear plate, or you can say shear splice connection. So let us start with the problem. So this is a regular problem. We have a beam of 3 plus 5 means total 8 meter length beam with some UDL of 10 kN per meter sprayed on length of 5 meter. At A there is a fixed support and at B this is a roller support. So as you know, there are three unknowns, that is moment at A, horizontal force at A, vertical force at A. But there is additional force we have to consider, that is vertical force at B. So there are four reactions and we have only three force equations. So this is an indeterminate structure. We cannot solve it using these three equations because there is one additional reaction is there. So in this case there are two types when you can verify it, or you can calculate the reaction using the methods, different methods to calculate the support reactions of indeterminate structure. But in some cases, you if there is internal hinge we provide here means in your problem, then this would be the indeterminate determinate structure. How that I'll tell you now. So this is an internal hinge we have provided at C, which is 3 meter from A. So in absence of the internal hinge, above structure is indeterminate as there are 4 unknowns instead of 3. So there is need to other methods of solving the indeterminate structures. So by adding the internal hinge, that is shear plies, it can be converted to determinate structure. So let us split the above system to calculate the reactions. So here I am splitting the total system into two different parts. So uh, first is the fixed support at A and C. At C there is a hinge support. At C there is internal hinge support. At B there will be the roller. So here you can see that there is MA, there is HA horizontal force, vertical RA, and in this case there will be the at C there will be the upward RC and the downward RC, and we have shown this HC in the equal and opposite direction, which ultimately we have to neglect because there is no force. So we are splitting the whole beam into two segments at internal hinges. Please remember this sign convention. RC would be downward at the left hand side of the internal hinge, and at the right hand side of the internal hinge it will be upward. So next is let us formulate the equilibrium equation separately for the each segment. So now for this case uh, we have three equilibrium equations and we can solve it. Here also we can solve it. So our structure is determinate now. Now we can try to find out the equilibrium. We will try to find out the unknowns. So I'm considering first the second segment. Here I'm considering the moment at C, which will be equal to 0, summation of moment at C equal to 0. So I'm considering 10 kilonewton per meter load intensity multiplied by 5 is the total load multiplied by the lever arm, that is 5 divided by 2. I'm considering moment at C. Then RB will produce the anti-clockwise moment, that is minus RB multiplied by a lever arm, that is 5 meter, and then I'll equate it to 0, and after solving the above equation I'll get RB as 25 kilonewton. So next equation I'll use, that is all the vertical forces I'll equate to 0. So RC will be positive upward, then minus 10 downward multiplied by 5 will be the total load, plus RB, then I'll equate it to 0. So after solving it I'll get the RC as 25 kilonewton. So this RC I am getting 25 kilonewton here, which is upward, and for the first segment it will be downward. So then I'll start with the vertical summation of forces uh, in vertical direction. I'll equate it to 0 for this segment only. So my equation will be minus RC will be downward, then RA is equal to upward, then I'll equate it to 0 and I'll add the value of 25 kilonewton RC here. So after solving it I'll get the answer as RA is equal to 25 kilonewton. So next will be the moment. So I'll consider the moment at A equal to 0. So RC positive means clockwise moment. RC multiplied by 3 meter is the lever arm. Then minus MA. MA is anti-clockwise moment. This is negative. Then I'll equate it to 0. So RC multiplied by 3 minus MA equal to 0. After solving this equation and adding the value of RC, which is equal to 25 kilonewton, I'll get the value of MA is equal to 25 multiplied by 3, which is equal to 75 kilonewton meter. So this is the way to solve these types of problems for the internal hinges. It is just for your information only, because in practical use there we never use these types of splices. We use moment splices. So that's all for this. There is one uh, problem we will take in the next video, that is uh, we will consider three spans, means the multiple spans, and to how then we will try to learn how to solve it. If you like the video, please like it and subscribe it and share it. Thank you.